In this lecture, I am going to discuss the design of split muff coupling. So first we'll see the design procedure. The design of split muff coupling has four parts. First one is the design of shaft, the design of hub, then the design of key, finally the design of bolt. So it's an advancement of muff coupling. Here the muff is splitted into two parts and it is held together by the bolts. Okay, so here the bolts is carrying some amount of load. So we have to design the bolt along with the shaft, hub and key. If the material properties of the coupling is not given in the problem, then we can assume the material as mild steel for keys, bolt and shaft. And for mild steel, the sigma 1 value is 90 Newton per mm square, considering all the factor of safety values. Then tau 1 is equal to 40 Newton per mm square. Then for hub, the material is cast iron with tau 2 is equal to 15 Newton per mm square. So the first four steps are common for both muff and split muff coupling. Only thing we are going to add the design of the bolts. So first step is calculation of shaft diameter. So first we have to calculate the torque by using the power and the speed. And after calculating the torque, substitute the torque in the stress equation and calculate the diameter. So after calculating the diameter, using the R20 series, standardize the size of the diameter. Then the second step is dimensions of the coupling. So the diameter of the hub is same like your muff coupling. The capital D is 2.5 times the smaller d and the length of the hub is 3.5 times the diameter. So here we are going to use a single key. So the length of the key is same as the length of the hub. So this is very important. In the case of muff coupling, we will use two keys. So the length is half of the hub length. But here we are going to use a single key. Then the width and thickness of the square sunk keys. Here we are going to use the square sunk key. So the width and thickness is equal to d divided by 4. The third step is same, checking the strength of the coupling. Consider the hub as a hollow shaft. So it is pi by 16 tau 2 outer diameter power 4 minus inner diameter power 4 divided by outer diameter. So here we have to calculate the value of tau 2. If the calculated value of tau 2 is less than the allowable tau 2, then the design is safe. The next one is checking the strength of the keys. So we have already designed the keys. So by considering the shear, calculate the tau 1 value and check whether it is less than the allowable stress value. Then considering crushing, calculate the sigma 1 value and check whether it is less than the allowable sigma 1 value. Okay. The fifth step is new for split muff coupling. First we have to select the number of bolt. So if the diameter of the bolt is less than 100 mm, then the number of bolt is equal to 4. In case of diameter in between 100 to 180 mm, the number of bolt is 6. And for diameters greater than 180 mm, we can take a number of bolt value as 8. Okay. Then the design of bolt, we know that the MT is equal to torque capacity of one bolt into the number of bolts, N. Okay. So first we have to calculate the torque capacity of one bolt. So here the bolt is subjected to axial load, okay, not torsion load. So the equation is MT is equal to pi square divided by 16. dB is the diameter of the bolt square into mu. So here mu is the coefficient of friction between the muff and the shaft surface. So if the mu value is not given in the problem, we can assume a mu value of 0.3. Then sigma 1 is for hub, then d is the diameter of the shaft and n is the number of bolt. So here we have to calculate the value of dB, that is diameter of the bolt. So after calculating everything, we can write all the dimensions along with this drawing, that is the last step, resulting dimensions. Okay. So we'll solve a problem on that. Design a split muff coupling to transmit a power of 5 kilowatt from a shaft running at 960 rpm. So here the power is given as 5 kilowatt, that is 5 into 10 power 3 watt, and the speed is 960 rpm. Assume suitable materials and stresses. Okay. So we have to assume the materials, and we can assume the material as mild steel for keys, bolt and shaft, and sigma 1 is 90, tau 1 is 40. So for hub, the material is cast iron and tau 2 is equal to 15 Newton per mm square. So the first step is calculation of shaft diameter. So first calculate MT from the power and the speed. So the MT value is 49.7 into 10 power 3 Newton mm. So after calculating the MT value, substitute the MT value in the tau 1 equation, that is 16 MT divided by pi d cube. Okay. So in the problem, the tau 1 value is given as 40. So substitute the value as 40. It is not 50. Then calculate the value of the diameter. So the calculated diameter value is equal to 17 mm. By using the R20 series, the standardized diameter is equal to 18 mm. The second step is dimensions of the coupling. So the diameter of the hub is 2.5 times the diameter. So it is 45 mm, and the length of the hub is 3.5 times the shaft diameter, that is 63 mm. Then the length of the key, here we are going to use a single key. So the length of the key is same as the length of the hub, that is equal to 63 mm. Then the width and thickness of the key can be calculated. Say here we are going to use a square sunk key. So the size is d by 4, that is equal to 4.5 times the diameter. So after calculating all the dimensions, then we can move into the checking section. So first one is checking the strength of the coupling. So consider the hub as a hollow shaft, substitute all the values and calculate the tau 2. So if the tau 2 value is less than the allowable tau 2 value, then the design is safe. Here the calculated tau 2 value is 2.9 Newton per mm square. So the design is safe. Then we can move into the design of keys. So first consider shear, substitute MT, length, width and calculate tau 1. Okay. So the tau 1 calculated value is 19.5 Newton per mm square. It is less than the allowable tau 1 value. So the design is safe. Then by considering the crushing, MT is equal to L into T by 2, sigma 1 into D divided by 2, calculate the value of sigma 1. Okay. So we have already solved many problems on the design of keys. So I am not going to go in depth in it. So calculate sigma 1, that is 38.6 Newton per mm square, and it is less than the allowable sigma 1 value, that is 90 Newton per mm square. So the design is safe. The fifth step is design of bolt. So here the diameter of the shaft is small. So I have considered the number of bolts as 4. Okay, so consider the number of bolts as 4. And substitute all the data. MT is torque. dB we have to calculate. Mu, it is not given in the problem. So I am going to assume a value of 0.3. Then sigma 1, it is 90. Then diameter of the shaft is 18. And the number of bolts is 4. So the calculated diameter of the bolt is 6.44 mm. Okay. So the last step, draw the split muff coupling drawing and write all the data as you have calculated. Okay. So that's all. This is how we have to design the split muff coupling. Now the tutorial problem, design a clamp coupling that is same as the split muff coupling to transmit 30 kilowatt at 960 rpm. The number of bolts connecting the two halves is 6. So here n is given as, that is number of bolts is 6. The coefficient of friction between the shaft and the muff is assumed as mu is equal to 0.3. Assume suitable materials and stresses. Okay. So you can use the same procedure to find the remaining dimensions. Finally you can draw the drawing and you can write all the dimensions.